Continuing on our 7.1 lesson, we're going to be looking at graphs of these polynomial functions. Now, so these are just the general shapes of how they normally look. Obviously, there are some differences in how each one will look, but in general, this is how these functions are going to look. Now, recall that the x-coordinate at the point where the graph intersects the x-axis is called a zero of the function. So any zeros that we have is whenever it crosses the x-axis. And what we want to be looking for is how does the degree compare to the maximum number of real zeros. Now, I'm going to take the liberty of assuming a couple things with our functions. So in our constant function, which is degree 0, so again, that would be something like y equals a constant, like y equals 2 or something. That's what this kind of looks like here to me is y equals 2. It's always just a straight line. Now a straight line, horizontal, should never cross the x-axis. Now the only exception to this would be if it was the x-axis, if it was right through there. But in general, if it's not y equals 0, if it's y equals some other number, it'll just be a horizontal straight line that will never ever cross the x-axis. So our zeros, there would be 0 of them. There are no zeros there. Now if we have a linear function, so again, say like y equals 2x or something, in this case, that one kind of looks more like y equals x plus 3 or something. Now those always make a straight line, but they will be kind of curved, a little more diagonal. And if you look at how many times they cross the x-axis, they should every single time hit once. So zeros, there should be 1 that they will touch on. Now if we look at quadratics, remember those always create this parabola. And sometimes they can point up, sometimes they can point down. And they don't always have to go through the x-axis. Remember, we can have a parabola that looks something like this. So it doesn't touch the x-axis at all, but we're going to say at most the maximum zeros, so max zeros, the most that it could ever touch the x-axis, 1, 2 times. Sometimes it'll only touch it once, remember, if that the vertex is right on the x-axis, but the most we can get is 2 out of it. Now, notice with these, our max 0 is the same as our degree. Degree 1, 1, 0. Degree 2, maximum of 2 zeros. Okay, let's look at cubic functions. I know we haven't worked a whole lot with these yet, but these will always kind of create almost a double parabola. Looks like it's starting going, starting from downward coming up, and then it looks like it's about to create this parabola, but it actually curves again. So it starts coming back down and then curves all the way back up again. So notice how it kind of changes directions twice there. So now the degree of this function is 3, and notice how 1, 2, 3 points that it can hit the zeros. So max zeros in this case, there are 3. Now again, it doesn't always have to do that. If it looked something like this, obviously we can see that it would only have 1 0 over here. That's possible. But at maximum, it can only hit up to 3. Same thing with this quartic. I'm not going to go in and explain it too much, but again, it kind of has almost a triple parabola effect. It starts going one way, coming all the way down, goes back up, goes back down, and then back up. Zeros, 1, 2, 3, 4. So max zeros, zeros, 4 for degree 4. And for degree 5, again, notice how it starts bottom here. I'm going to use red. Goes up, down, and back up again. So max zeros, 1, 2, 3, 4, 5. So the max zeros always is the same as the degree of your polynomial function. Now, another thing to notice is that the graphs of even degree polynomials, so when we had 0, when we had, I'm going to kind of circle these, the 0, 2, and 4, the end behavior was the same as the start behavior. And by that we mean the behavior for 0, degree 0, means it's just not changing. It's never doing anything. It's not going up or down, so it doesn't change at all. End behavior for degree 2, as we're moving left with our x, so as x is going this way, our y is going up. And also, as our x goes right, our y goes up. So our behavior is that up or down as we go left to right. And it's going up in both instances here. Now again, if it was a parabola that looked like this, its end behaviors would both be going down. But we know that they're always the same. Same thing with this degree 4. Leftward, it's going up, and rightward, it's going up. It's always the same. Now if we look at our first degree, so an odd degree, left is going down, but right is going up. Degree 3, left is going down, right is going up. Degree 5, left is going down, right is going up. So, for even degree polynomial functions, we would say that the end degrees are the same. For odd degree polynomial functions, their end behaviors are different. Now, an end behavior is the behavior of the graph as x approaches positive infinity or negative infinity. And again, by that I mean if x is approaching positive infinity, I'm going to give us some space on this one. As x approaches positive infinity, that means as we're moving to the right. So then what is f of x doing? What is that y value doing? Well, it's going up. So as x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, that means moving to the left, f of x approaches negative infinity. That means going down. So it's just kind of another way to say things, making sure you get the right notation, the right words down. So let's go over what we talked about there. Degree, when it is even and the leading coefficient is positive, then the end behaviors would look something like this. F of x approaches positive infinity when as x approaches negative infinity. So again, as x approaches the left or negative infinity, f of x approaches positive infinity. So it's going up. So whenever we have even degree with a positive coefficient, as x approaches negative, as x goes to the left, then f of x will approach positive infinity. F of x will go up. And on the other side, as x approaches positive infinity, f of x approaches positive infinity. Both will go up. Now if we have odd degrees with a positive leading coefficient, then as x approaches positive infinity, as x goes to the right, f of x will approach positive infinity. This one will go up. Same thing though, same graph, with odd degree and a positive leading coefficient. As x approaches negative infinity, so as we go leftwards, our f of x, or our graph, will approach negative infinity. Will go down. Moving right along, if we're back to an even degree function and our leading coefficient is negative. So again, the example they give is a parabola that's going downward. As x approaches negative infinity, so as we go to the left, f of x approaches negative infinity. So we are going down, and this will happen in every single time that we have a even degree polynomial function with a leading coefficient that is negative. Doesn't matter if it's 2, 4, 6, 8, whatever degree it is, they'll all look something like this. When their x approaches positive infinity, so as they're going to the right, their f of x will approach negative infinity, so they will go down. That happens every single time in these cases. And the last case that we have is when the degree is odd and the leading coefficient is negative, then as we start on the left side here, or as x approaches negative infinity, our f of x will approach infinity, will be going up. And as f of x approaches positive infinity, so as we go right at the end of our graph will approach negative infinity. F of x approaches negative infinity, or we're going down. So the graph of an even degree function may or may not intersect the x-axis, depending on its location in the plane. If it intersects the x-axis in two places, that means it has two real zeros. If it does not intersect the x-axis, the roots of the related equation are imaginary, and they cannot be determined from the graph. If the graph is tangent to the x-axis, as shown above, like in this case here, you see it touches just one point, it's tangent to the x-axis. Then there are two zeros that are the same number. The graph of an odd degree function always crosses the x-axis at least one time. And that makes sense, because if one is going, like in this case, one is going down and one is going up, well, sometime you're going to have to cross that x-axis. So that it crosses the x-axis at least once, and thus the function always has at least one real zero. So if we want to take an example looking at some graphs of polynomial functions. So if we wanted to, for each graph, describe the end behaviors, describe or determine whether or not it represents an odd or even degree polynomial function, and state the number of real zeros. Well, let's look at A here. Actually, let's make sure. Okay, so for the end behaviors, well, as x approaches negative infinity, so as we're going to the left, our f of x approaches negative infinity. So f of x approaches negative infinity, sx approaches, oops, well, they started with the positive direction. So as we go to the right, and we're going down, as we go to the left, we're also going down. It is an even degree polynomial function, and we know that because they're going down both times. So it has to be even. And it intersects at 2 points here, so there are two real zeros. All right, let's look at B. As x approaches positive infinity, our f of x approaches positive infinity. And as x approaches negative infinity, our f of x approaches negative infinity as well. Since one is going down and one is going up, it is an odd degree polynomial function, and it looks like it crosses the x-axis only once, so there is only one zero. And lastly, if we are looking at this one here, just a parabola, as x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x also approaches negative infinity. So those are the end behaviors. And since the end behaviors are the same, they're both going up, then we know it's an even degree polynomial. And it looks like it actually never crosses the x-axis. So there are no real zeros, none at all. And that would be the end of 7.1.